One of the things that we need to consider within any type of financial strategy is the fact that working out what's going to happen in the future cannot absolutely be guaranteed. And there's always going to be a chance that the predictions that we've calculated, A, might not happen, or B, if they do happen, it might not be exactly as we've planned it. And there could be some sort of variation or some scope between which these figures are going to be acceptable. To be able to understand and calculate how much these things can vary, we need to understand the basic concept of normal distribution. Normal distribution is a type of probability that looks at the likelihood of occurrences happening. And one of the most common features of normal distribution is its bell-shaped feature. We can actually plot normal distribution curves onto a graph to depict the likelihood of events actually happening. And one of the characteristics of normal distribution is, first of all, it is symmetrical, and it is symmetrical around the mean. Now, the mean is simply the average. The mean is the average of all the events that could possibly happen, added all together and divided the amount of occurrences that you've actually looked at. And this distribution is symmetrical about that point, which means that half the time you will be below the mean and half the time you're actually going to be above the mean. Now, there are some other features that we need to consider for normal distribution. Now, some of this is mathematical, but don't worry too much about where these figures have come from. You will not be expected to derive any of these figures in the examination. You just need to be aware of the basic concepts that actually go with it. The first thing we need to consider is what's called the standard deviation. And this is looking at how widespread the results are from the mean. Basically, what we could have is a very narrow spread of results around the mean. So you get an average figure of £10,000 and your results could be only a little bit above 10,000 or slightly below 10,000. Alternatively, your results could be very, very spread out, where you get an average figure of 10,000, but it could go as high as 50,000, but you could end up with a loss of 40,000. We need to know how spread out our potential results are. Now, the characteristics of the standard deviation, if you were to calculate the results that were one standard deviation below the mean, what you would discover is approximately 34% of all results would lie between the mean and that figure that was one standard deviation below the mean. Because of the symmetrical nature of normal distribution, then there will also be 34% of the results will lie between the mean and one standard deviation above the mean. And obviously, therefore, that means that 68% of all of your results will lie between plus and minus one standard deviation of the mean. And that is pretty much all that you need to know about standard deviations. It is a measure of how much is actually between the mean and that particular point. And what we're going to look at is the bigger the standard deviation is, then that means that the whole result is more widespread. If the standard deviation is very, very small, what it means is that 68% is between plus or minus one standard deviation of the mean, which is going to be a very narrow range. Now, what we're going to do is use this knowledge along with our normal distribution tables given to us in the exams, and we're going to be able to work out what is the probability of certain events occurring. To do that, we're going to use what's called a z-score, and to work this out, it is simply x minus mu divided by sigma, where x is the result we are considering, mu is the mean, and this is the standard deviation. what this is going to work out is, in effect, any result that we're looking at, to work out the likelihood of that occurring, we're going to express this in terms of the distance away from the mean divided by the standard deviation. It will tell us how many standard deviations we are away from the mean, and from the tables in the exam we'll be able to work out the probability. Now, for those of you who've never come across normal distribution before, this concept may seem particularly difficult to start off with, but with the use of a simple example we can see this is always going to be relatively simple to calculate. So consider the following. A simulation has been used to calculate the expected value of the project and is deemed to be normally distributed with the following results. You have a mean of $40,000 net present value positive with a standard deviation of 21,000. Calculate the following: the probability that the net present value of the project will be greater than 0, and then calculate the probability that the net present value will be greater than 45,000. If you are not familiar with normal distribution, then I strongly advise on any sort of example like this, you always draw yourself a basic diagram to try to understand exactly what it is we are calculating. So here we have a basic normal distribution curve, and we're told in the question that the average is 40,000. We are also told that the standard deviation is 21,000. And the first part of the question asks us to calculate the probability that the net present value is greater than 0. Now, we obviously would like to know this because projects that have a negative net present value are going to be rejected, and projects with a positive net present value are going to be accepted. So what we're trying to work out in the first part of this question is what is the likelihood that this particular project is going to be accepted. Detail on the diagram exactly what we are trying to calculate. We are looking at a particular figure where the net present value is 0, and that is going to represent our x value. We're going to use the tables that are given to us in the examination, and the tables will give us the probability of the events occurring between the mean and the figure that we are considering. So the table is going to give us this shaded area. However, the question asked us to calculate the likelihood that it's going to be greater than 0. Now, the shaded area only gives us part of the likelihood that it's going to be shaded. The total likelihood is from 0 all the way through to the other half of the graph. What we therefore need to do is take the figure from the table that will give us the shaded area, and because of the symmetrical nature of the diagram, everything to the right hand side of the mean is going to total 50%. So if we take the shaded area probability and then add on the 50%, then we will know the probability of the events actually being greater than 0. So using the formula that we discussed before, Z equals the figure that we are calculating minus the average divided by the standard deviation. So we're trying to work out the probability of it being greater than 0. We know that the average is 40,000, and we can divide it by the standard deviation of 21,000. This will give us an answer of 1.90. And due to the symmetrical nature of normal distribution, we can actually ignore the fact that it's negative and just treat it as a positive number. From the normal distribution table, we can then read off the corresponding value for 1.9. and the corresponding value is 0.4713. Now remember, that only gives us the probability of the shaded area that we discussed. So the probability of this project having a present value that is between 0 and 40,000. But to work out the probability that's going to be positive, we're also going to need to add on to that the other half of the table, which has a probability of 0.5, which gives us an overall probability of 0.9713. Roughly 97%. So what this is fundamentally saying, that we have a 97% chance that this project will have a net present value that is greater than 0, and therefore we should be accepting this project. If we then consider the second part of this question, it said calculate the probability that the project is going to have a net present value that is greater than 45,000. Again, start off by a nice simple example or diagram, just to make sure that we have all the figures that we actually need. The average is 40,000 and the standard deviation is 21,000. The figure that we are considering here is a net present value of 45,000, which is going to be approximately here. Don't worry if it's not to scale, you're just trying to get the idea of which figures you are trying to calculate. Now, by using the table, it's going to give us the probability of the area between the figure we are considering and the mean, which is this area here. However, the question wanted the probability is going to be greater than 45,000, which is represented by this area here. But keep in mind that everything to the right-hand side of the mean has a probability of 50%. Therefore, if we take the area that is shaded, which is given to us by the table, deduct that from the probability of 0.5, then we will end up with a probability that we're going to be greater than 45,000. So using that formula again, Z equals the figure that we are considering less the average divided by the standard deviation. This will give us 45,000 minus the average of 40,000 divided by 21,000. Which gives us a value of 0.24. We could then look at the corresponding figure from the table. So from our normal distribution table, we have a value of 0.0948. Now, remember what this is calculating. This is calculating the probability of that shaded area between 40,000 and 45,000, but what we are trying to consider is the probability of being greater than 45,000. So, if we take 0.5 and subtract that probability of 0.948, we have 0.4052. So we have approximately a 41% chance that the net present value is going to be greater than 45,000. Why would we want to know something like this? Well, the main reason could potentially be that we might be considering two projects and we can only do one of them, and maybe the other project has a guaranteed return of 45,000 net present value, where this one only has a 41% chance of being greater than 45. and as a result of that we therefore may consider the other project instead.